All right, so we're still working with transformations of graphs of functions. So we looked at individual transformations. We want to focus on complex transformations where we have a series of transformations, multiple transformations together. So we want to learn how to graph using that. So first of all here, I have this function y equals minus, parentheses, x plus 1 cubed, and then minus 1. So we want to identify the parent graph first of all. So y equals x cubed, right? And after that, so you always want to do your transformations from left to right. After that, we have, so basically you start with the parent and then you focus on the transformations. So parent and then transformations. The first transformation is this minus out in front of the house. So that's going to be a reflection about the x-axis, right? Reflection about x-axis. And as you proceed from left to right, you go encounter this plus 1 that's inside of the house. So what does that mean if you have a plus 1 inside of the house? Well, that's going to be a horizontal shift. It's going to be in the opposite direction of the sign because it's inside of the house. So it's going to be left 1. And we go on to, I guess, purple or violet. We have a minus 1, so subtract 1 outside of the house at the end. That transformation is outside the house. It's going to be vertical motion. It goes in the direction of the sign because it's outside the house, so it's going to be down 1. So let's start off with the parent. X-axis and y-axis. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1. Negative 2, 3, 4, 5, 6, 7, negative 8. So on the x, that's on the y-axis. Now on the x-axis, we're going to have 1, 2, and negative 1, negative 2. So graphing the green function, y equals x cubed, the parent, you have 0 squared is 0. I'm sorry, 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Then we'll do negative 1 cubed is negative 1. Negative 2 cubed is negative 8. You'll have this. Okay, the next thing we're going to do in red, we're going to reflect it about the x-axis. So we're going to take this point here at 2, 8 and flip it upside down to 2, negative 8. We're going to take the point at 1, 1 and flip it upside down to 1, negative 1. We're going to take the point at 0, 0, the inflection point, the central point, it stays. We're going to take the point at negative 1, and flip it upside down to negative 1, positive 1. And we're going to take the point at negative 2, negative 8 and flip it upside down to negative 2, positive 8. So we'll get something like this. Maybe that wasn't ideal. Let me try to be a little more careful about connecting these. Okay, that's okay, I guess. Okay, so we reflected about the x-axis. Now we're going to shift everything down 1 unit. So I'm going to start with, no, we got to do left. I haven't done left yet. Okay. Let's make sure we take all our red points and move them left 1. So I'm going to take my far left red point, which is negative 2, 8. I'm going to move it left to negative 3, 8. They're cutting grass here at the university. I'm going to take my next red point on the left at negative 1, 1 and move it left 1. I'm going to get negative 2, 1. I'm going to take my next red point at the origin and move it left 1, and it's going to become negative 1, 0. And then I'm going to take my red point at 1, Well, let's connect these. Okay, now let's start on those points to the right of the origin. We're going to take 1, negative 1, 1, negative 1, and move it right 1 to 0, negative 1. And then the point at 2, negative 8, move it right 1 to 1, negative 8. So let's connect these. Okay, I'm going to do one final step. I'm going to move everything down 1 now. It's going to be a violet color. Let's take our left endpoint, negative 3, negative 8, and move it down 1. Let's take our left blue endpoint at, what is it, negative 2, 1. Let's move it down 1 to negative 2, 0. And let's take our inflection point, which is at negative 1, 0 now, and move it down 1 to negative 1, negative 1. And let's connect these. Okay, now let's take our next blue point, which is at 0, negative 1, and move it down 1. And let's take our rightmost blue point, which is at 1, negative 8, and move it down to 1, negative 9. And let's connect our violets. So our final graph is the violet one. I'm going to say this is y equals minus, parentheses, x plus 1, quantity cubed, minus 1. So the inflection point is right here at negative 1, negative 1. Now, if you don't want to draw all the intermediate graphs, you don't have to. You can just draw a final graph. Sometimes I like to do that. I often like to do that. But I'm showing step by step the thought process involved. You can do these transformations mentally and just draw a final graph if you like. Number 2. Now let's do y equals, let's do minus 3, absolute value of x minus 2, close the absolute values, plus 1. So here our parent graph is y equals the absolute value of x. And we're going to have some transformations. We're going to have a minus out in front of the house. In addition to that minus out in front of the house. So what does that minus do out in front of the house? That is going to be a reflection about the x-axis. Remember, when the minus is out in front of the house, it flips it upside down about the x-axis. And then we have this 3 connected with the minus sign. So the 3 is going to be a vertical stretch. Vertical stretch. So vertical stretch by a factor of 3. Now, some people put those two together. They put the minus and the 3 together, and they just say, okay, you just multiply all the y values by minus 3, rather than breaking it up into 2 steps where you're going to flip things upside down and then stretch it out by a factor of 3. They just multiply all their y values by negative 3, and that does everything in one step. That basically reflects about the x-axis and stretches out by 3 all at the same time. So that's probably what I'll be doing when I go through this. I'll put these together into one step. Okay, so after that, let's see, what do we have after that? Going left to right, we have this minus 2 inside of the house. Remember, when it's inside of the house, it's horizontal. It's going to be the opposite of the sign, so it's going to be right 2. We're going to move right 2. And then finally, outside of the house, we have a plus 1. So adding 1 outside of the house is going to be vertical motion. It's the same direction of the sign when it's outside of the house, so it's going to be up 1. So let's start off with our absolute value graph. if I can draw it. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2. 1, 2. Okay, so the absolute value function. So you plug in 0, absolute value of 0 is 0. You plug in 1, the absolute value of 1 is 1. You plug in 2, the absolute value of 2 is 2. Plug in -1, the absolute value of -1 is 1. You plug in -2, the absolute value of -2 is 2. And you get this V for the absolute value graph. So my next task, I'm going to combine the minus out in front of the house and the 3 out in front of the house. I'm going to call that multiplying the y values by -3. So those are, all the y values are going to get multiplied by -3. So I'm going to start on the left side. This left endpoint here, the y value is 2. We're going to multiply 2 by -3, and we're going to get -6. So our point's going to become -2, -6. Okay? My next point here is, let's see, -1, 1. So the y value, pay attention to the y value. The y value is 1. We're going to multiply 1 by -3, and we're going to get -3. So we'll have -1, -3. In the center, the origin, or the vertex, the y value is 0. You multiply 0 by -3, and it stays 0, so you have 0, 0 still. Okay, so the next point, this one here, 1, 1, you multiply the y value 1 by -3, and you just get -3, so you got 1, -3 as a point. And finally, for the rightmost point here at 2, 2, the y value 2 gets multiplied by -3, and you get -6 for your y value, so you get 2, -6. So we're just multiplying the y values by -3. So that is a reflection about the x-axis, flips upside down, and it stretches things out by a factor of 3 vertically. So we did that all in one step rather than breaking up into multiple steps. Okay, so the next thing I want to do, I want to shift things right 2. So I'm going to make 2 more marks on my x-axis if I can get my pen to work. So I'm going to shift everything over by 2 to the right. So I'm going to go, let's start with the rightmost point, -6, 2. -6, 2, no, I'm sorry, 2, -6. 2, -6 is going to shift right to 4, -6. 1, -3 is going to shift right to 3, -3. 0, 0 is just going to shift right to 2, 0. And on the right side, we're going to have this downward piece of the V. Right piece of the V, I should say. Let's go to -1, -3. We're going to shift right 2. We're going to get 1, -3. And let's go to -2, -2, -6, and move right 2 to 0, -6, and connect these. Okay, I should be making dashed lines here. It would be better to make dash lines. Okay, now we're going to shift everything up by 1 in violet, and this will be our final graph. So, come on, violet, work. I'm going to take my rightmost endpoint, which is currently at 4, -6. I'm going to shift it up to 4, -5. I'm going to take my next right endpoint at 3, -3, and shift it up to 3, -2. I'm going to take my blue vertex at 2, 0. I'm going to shift it up to 2, 1. I'm going to complete this right-hand side of the upside-down V. Okay, now I'm going to take, on the left, 1, -3, and move it up 1 to 1, -2. And 0, -6, I'm going to shift up to 0, -5. I'm going to connect the left sides. And you have this upside-down V. That's your final graph. This is y equals -3, absolute value of x minus 2 plus 1. So the purple is the actual final graph that gets graded So if you want to just put that graph in there with the you have to have accurate points though, those accurate points. That's fine. I'm showing the thought process though, the transformation thought process. You can do it all in your head if you like. All right, so let's go on. Maybe do one more in this video and then go back in another video to do some more later. Yeah, I'll do that, I think. I think I'll come back in a video. Okay, I'll do one more example in this video and come back in another video to finish up. I don't want to put too much time into these videos. It's not a good idea to make a video over a half hour. They say usually you want to do like 15 minutes. That's ideal, but yeah. Okay, so let's do number 3. This will be the last one for this video. We have y equals 4, parentheses, x plus 3 squared minus 1. So here, where'd my pen go? My parent function is y equals x squared. It's called the squaring function. In addition to the squaring function, we have multiplication by 4 out front of the squaring function. That's going to be a vertical stretch by 4. Also, we have a plus 3 inside of the house, inside of the function. Inside of the function is going to be the opposite of the sign, and it's horizontal, so it's going to be left 3 shift. And then outside of the house, we have a minus 1. Outside of the house is going to be a shift either up or down vertically. It's going to go in the direction of the sign, so it's going to be down 1. Okay. Now let's start with our squaring function. One, 2, 3, 4, negative 1 on the y, and on the x, 1, 2, and negative 1, negative 2, negative 3, negative 4. The squaring function, we're going to take 0 and square it. We get 0. 1 squared is 1. 2 squared is 4. I'll connect these on the right and on the left. Negative 1 squared is 1, and negative 2 squared is 4. Connect these. You get a U shape, right? The parabola. Okay, so the first thing we're going to do, we're going to vertically stretch everything by 4. So that means we're going to have to multiply the y value by 4. And I did not leave myself enough space, so I am in big trouble. Okay, so let's redo this. Let's try this one more time. Let's try this one more time. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. That'll work. Okay, so I want to graph, so y-axis here. I want to graph my parent again. So 0 squared is 0, 1 squared is 1, 2 squared is 4. Negative 1 squared is 1, negative 2 squared is 4. That didn't work out, did it? Let's try it a little better than that. Okay, so the first thing we're going to do, we're going to stretch by a factor of 4. So that means we multiply the y values by 4. Okay, let me start on the left. See negative 2, 4, this point here on the left. That point right there, negative 2, 4. We're going to take the 4, the y value, multiply it by 4. We're going to get negative 2, 16. So 4 times 4 is 16. So we're going to get negative 2, 16. Now let's take our next left point, which is at negative 1, 1. Take the y value of 1 and multiply that by 4, and we're going to get negative 1, 4, because 1 times 4 is 4. Now let's take the center, 0, 0, the y value 0, multiply 0 by 0 by 4, and you're going to get, for y value 0, you get 0, 0. So on the left side, you get this. Okay, now let's take 1, 1. The y value is 1. When you take the y value of 1 and multiply by 4, you get 4. So you get 1, 4. And then let's take that right point of 2, 4, and multiply the y value of 4 by 4, and you get the y value of 16. So you get 2, 16 for that right endpoint. And connect those. Okay, so you get this kind of vertically stretched out green graph. It turns into this red graph. Now we're going to shift everything left 3. So I'm going to take negative 2, 16. Negative 2, 16 on the left and move it to the left 3. It'll become negative 5, 16. I'm going to take the next red left point, which is negative 1, 4. I'm going to move it left 3, and it's going to become negative 4, 4. Now I'm going to take the origin 0, 0 and shift it left 3. I'm going to get negative 3, 0. So connecting the left points, we get something like this. Okay, now I'm going to go to the right. I'm going to get 1, 4, the red endpoint of 1, 4. It's not an endpoint, it's a 1, 4 point on the right side. 1, 4. Move it left 3, and it becomes negative 2, 4. Now I'm going to take the right point, which is 2, 16, and move it left 3, and I get negative 1, 16. And here I'm going to connect these. So all the red points have been shifted 3 to the left. We got the blue. Now we're going to do one more final step. We're going to move everything down 1. So down 1 is going to become my violet. So I'm going to move the negative 5, 16 down 1, it becomes negative 5, 15. I'm going to take negative 4, 4, and move it down 1, it becomes negative 4, 3. I'm going to take negative 3, 0, the vertex, and move it down 1, I'm going to get negative 3, negative 1. I'm going to take negative 2, 4, move it down 1, I'm going to get negative 2, 3. I'm going to take negative 1, 16, move it down 1, I get negative 2, 15. So connecting these with a solid curve does something like this in purple. So the purple is the final graph, and this is the graph of y equals 4 times x plus 3 quantity squared minus 1.